we are going to discuss coordinate covalent bond. We already discussed about much about covalent bond. Now coordinate covalent bond. This is also called as a dative bond. Dative bond, right? Now this bond is formed by donating of pair of electrons from one atom or molecule to another atom or molecule. Here not mutual sharing of electron. One is donating, another one is accepting. For example, if we are taking NH3 already it is having lone pair of electrons, that you know very well, right? BF3 or BCl3, BF3 we will take, BF3 means this is the BF3. Around the BF3, how many electrons are there? 6 electrons. It is electron deficient. We know very well. Now what is going to do? This lone pair of electron is donating to the BF3 molecule. This is also molecule, this is also molecule. That's why I written as one molecule to another atom or molecule, wherever it may be. So NH3, this lone pair of, not NH3, nitrogen only. Nitrogen is donating the pair of electrons to the BF3. So it is accepting the pair of electrons. Who are donating the pair of electrons, those are called as a donor. Who are accepting the pair of electrons, that is called as acceptor. To donate the pair of electrons, it should be has more electrons which are not involving in the bond formation. So this is called as electron rich molecule. Why it is electron rich molecule? It is having one lone pair of electron which is not involving in the bond formation. Then only it can give. And this need to accept means it should be has less number of electrons, no? So it is called as electron deficient. We already discussed this one. Deficient molecule. Deficient molecule. And come to the acid base. Are you remember or not? Who are donating the pair of electrons? They are called as a Lewis base. Lewis base. So 3 type of names are there here. Here also 3 type of names are there. This is Lewis acid. Who are accepting the pair of electron? That is called as a Lewis base. Who are donating the pair of electrons? That is Lewis base. Now come to how they are forming the bond. N2 boron, BF3, NH3. This bond is coordinate covalent bond. Mostly this bond we are representing in square brackets. Coordinate covalent bond represent with arrow. This arrow is from donor to acceptor. Donor to acceptor. We will get these type of compounds in complexes. Complex compounds. So this is coordinate covalent bond. Coordinate covalent bond. That's all about a coordinate covalent bond, and this is also called as dative bond. We are going to discuss the questions now. Which does not obey the octet rule? Which does not obey the octet rule means which is not having 8 electrons around the molecule. Now NH3. NH3 you know very well. This is NH3 structure. In NH3 8 electrons are there. So it is obeying. CH4 obeying. H2O also you know very well. This is H2O obeying. So BaCl2 is example for octet rule, which is not obeying after that. Due to the lateral overlapping results the formation of lateral overlapping results the formation of which type of bond? Pi bond, right? Pi bond. And which of the following is an ionic bond? Remember, one thing is there to remember the ionic bond. If any metals are there, that is ionic bond. Okay, you can remember easily. Metals are there means obviously they will form the ionic bond. Which is the metal? Calcium is a metal, so mostly it is ionic. Remaining all you can understand. This is covalent bond. HCl we see, H2O we see, H2S also, like that on. And bond angle of H2O we already discussed BSc-PR theory. Due to the lone pair repulsions, it became to the 104 degrees, which is near to 104, this one. And which of the following contains only sigma bond? Only sigma bond. C2H2, I already given that C2H2, CH2, double bond CH2. Means in this pi bond is there. In C2H2, CH double bond CH2, double bond CH2. So it is not only sigma bond. O double bond O, it is not only sigma bond. N triple bond N, it is not only. NH3, this is NH3. All are sigma bonds only. This is example. This is example. After that, here one very important thing is there. If you observe the X and Y, they given two elements X and Y. They have given the configuration also, X and Y configuration. What is the molecular formula they are going to form? Example, for example, X with the configuration 1s2, 2s2, 2p6, 3s2. To get octet configuration, it is easy to lose 2 electrons. More means X is able to form X plus 2. Y configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So it is easy to gain 1 electron. Now these electrons discharge to here x1, y2. So the molecular formula is xy2. This is the answer. Now, which of the following is non-polar in nature? Non-polar in nature means the bond between same type of atoms. Sulfur only there, remaining all are oxygen more electronegative, chlorine more electronegative, nitrogen more electronegative when comparing with the hydrogen. So they are polar. Same molecule is a sulfur only. So S8. Next, which shows the multiple bonds. Multiple bonds, HCl. Hydrogen and chlorine is able to form only one bond. So it is not. BeCl2, you know this structure. BeCl. Cl2. No. CO2. Oxygen is able to form the double bond. So this is the structure of CO2. Multiple bonds. Multiple bond means either double bond or a triple bond. If you see the CH4, this is CH4. Hydrogen. All are single bonds. Next. A triple bond is made up of, triple bond we already discussed, one sigma bond remaining 2 or pi bonds, where it is one sigma bond remaining 2 or pi bonds. This is about chemical bonding.